Hi everyone, today let's solve the problem number 84, largest rectangle and histogram, right? So what the question states here, we have been given an array of heights. So you can clearly see here, we have been given array heights where each element represents the height of the histogram. So here each element represents the height of the histogram bar, right? And the width of the each bar is exactly 1, and width of each bar, here you can clearly see this. I'm speaking of, just give me a second here. Width of each bar here, this one, this one, this one. So width of each bar is exactly 1. Basically width of every bar that is present in the histogram is 1. We have to find the area of the largest rectangle that can be formed using one or more contiguous bars. So again, we have to find the area of largest rectangle, means greater in size, right? So here we have to find the area of largest rectangle that can be formed using one or more contiguous bars, one or more contiguous bars. So here in the this one you can clearly see, here in the example you can clearly see this will be quite obviously 10 here. So this they have given 10. So this is the largest histogram that can be formed. This is the largest histogram, largest rectangle, sorry, that can be formed using one or more contiguous bars. Here we have made use of two bars, right? So this one and this one along with this one. So here this is the largest rectangle that can be formed using one or more contiguous bars. So we need to return 10 in this case. We need to return 10 in this case. Same goes with example 2 as well. Just give me a second here. What happened? 1 second. Yeah, here you can clearly see we have 2 and 4 here. We have 2 and 4. So we can just represent this one. Either we can consider this one or the 4 directly, right? So input will be heights of 2 comma 4 they have given, and the output that we have got here as 4, right? 4. Here the largest rectangle that can be formed using one or more contiguous bar is 4, right? I hope the question part is completely clear. I hope the question part is completely clear, right? Let's do one thing. Let's write the code and discuss the complexities. Let's write the code and discuss the complexities. So here first what we'll be doing, we'll be making use of the length of the heights. We will be making use of the length of the heights every time. So let me assign that one to the variable n. So this will be heights dot length. This is fine. So and let me do one thing. Let's make use of the stack to hold the indices. So I'll just go with stack here. So this will be integer, stack of integer, this one stack equals new stack. So I hope this part is clear, right? So we are just making use of the stack to hold the indices. Also we need to calculate the maximum area, right? So let's do one thing. Let's go with maximum area. Let's assign the maximum area to, or let's initialize the maximum area to 0, right? So now we are left with the this one traversal part, or yeah, we have to go with the iteration now, right? So let's make use of the for loop here. This will be int I equals 0, I less than or equal to n, then I plus plus. So within the for loop, what we'll do, for the last iteration we have to take the height as 0, because we have to flush the remaining stack part, right? So we have to flush the remaining stack part. We are going with the stack. Basically we are going with a monotonic stack here, if you observe correctly, right? So here in this case, for the last iteration we have to take the height as 0 to flush the remaining stack. So here in this case I'll just come int, let me consider current height here. Current height equals, so this will be I equals n. If it is okay, then we'll display 0, or else if current height I equals n, then we'll go with 0. If not, then we have to display the heights of I, iterated value of the height. So this is fine. So the next step is we have to maintain the increasing stack. We have to maintain the increasing stack if we can consider more than one, this one, right? uh, Longest, I mean the largest area we are considering, we can consider any number of bars, right? So here in this case we have to maintain the increasing stack. So this one will be while of not stack dot is empty and current height. So if it is less than heights of stack dot peak here, stack dot peak. So this one, yeah, this is fine. Stack dot peak. Then within the while loop, what we have to do, we have to go with the index of height to calculate the area. We have to calculate the area. So we have to go with the index of the height to calculate the area. So I'll just go with the variable name top index here. This one will be stack dot pop. This is fine. And also let's consider the variable height and assign to height of the top index. So let me copy this one and paste it over here within the array. So after this part, we are left with certain things. Now let's move on with one important edge case. Nothing but here, if the stack is empty, width, we have to consider the width spans from 0 to 1. Right? If the stack is empty, we have to consider the width spans from 0 to not 1, 0 to I basically. Right? Sorry, I got confused here. So this one has to be int width equals stack dot is empty. If it's true, we have to return I. Else if it is not true, we have to go with I hyphen stack dot peak. Sorry, here I will not be going with a pop. Basically, this will be peak minus 1. Right, what we are doing here, if the stack is not empty, then we are going with a considering the width spans from 0 to I basically. Right, next let's go. We have to calculate the area and we have to update the maximum area every time if we find any. Right, so let's calculate the area. Area equals nothing but, so here height into width, height into width. Area is nothing but here height into width, and also we have to update the max area every time we find if we find the max area. Right, max area equals, we can directly make use of the math.max here again. So let me copy this one here. Max area, sorry, this one will be max area comma area. This is fine. So after this step, we have to push the current index, nothing but here this will be stack dot push of I. So this is fine. So the final step here is we have to return the maximum area. So this will be max area. This is fine. We have to return the maximum area. So let me format the document once. So this is it for the code. So this is it for the code. We didn't discuss the approach in a I didn't elaborate the approach, right? So we didn't discuss approach in depth here. So coding itself was necessary. Coding while writing the code itself, I thought of explaining for this particular problem, as it was easier, right? While explaining, while writing the code itself, I explained the things. That's it. So I hope the coding part is completely clear. Let's quickly discuss the complexities for the code that we have written. Let's quickly discuss the complexities for the code that we have written. So the time complexity would be big of n, because here we are going with the each bar that is pushed and popped at most once. We are iterating through the each bar that is pushed and popped at most once. And what would be the space complexity then? The space complexity would be big of n as well, because in the worst case all the indices are pushed into the stack. We might consider all the indices, right, in the memory, or in the worst case all indices are pushed into the stack. So space complexity would be big of n as well. So the time complexity and the space complexity would be, for the time complexity and the space complexity for the code that we have written as big of n in this case. Right, I hope the complexities part is completely clear. Right, I hope the solution part is completely clear along with the approach and the complexities. Right, for now this is it. Thanks for watching, guys.